fun. Yeah, good that you did.
This is gonna be T1. This is gonna be T1.
I don't care.
T1 is trash for both.
You got it?
Oh.
Alright, because while we're waiting for my notes to come up, I thought they were coming up. There they are. Oh, that didn't work out well, did it?
No, Mr. Kim's banning us.
Why would he do that?
Because it's Mr. Kim.
Hey, he has a heart for you guys. If you don't know that, you should talk to him. Alright, real quick on the calendar, if you guys notice, here we are on Monday. We're starting 8.2. Our goal is to have a test next Wednesday. People that are gone on Thursday and Friday. Because you guys should all be here for the musicale on what? Even if quiet people are leaving early, you're here for period 2. Thursday and Friday, we are doing one entire section, so please, please, please make sure to check out the video. Please, please, please. Ooh, we might even be covering. Ooh. We're covering 1.5 sections, so make sure you check out the video. It's not as bad as section 8.1, but still important. And otherwise, I think we're good to go. So, anyone going to be gone for AP Gov tomorrow? Okay. Don't worry. If it's not you, it doesn't apply. Alright, let's go quick. I got the video started. I just want to fill in stuff while we copy it down. So, we already figured out that these ones are, Ricky Whisper, 2, -1, -3, and 0. Did that. In order to add, they have to be, oh, we did this one too. We circle, and 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 dot, 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 after equations, x equals 2 and y equals 3. Dun, 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 dun. Okay. We added these two together, 0 identity, additive identity matrix. We get 0, 1, -2, 1, 2, and 3. These ones, we said empty set. Give me one reminder as to why. Yeah. So here's anything, since they are of different, what? Order. Perfect. Okay, number next one. This is what you guys are supposed to be doing when I got the computer back up online. Working. Alright, when you guys added A plus B, what did you end up with? First of all, what order is the matrix? 2 by 2, and what were the entries?
-2, 1, 7.
Usually we read a matrix like the calculator puts it in. We go across and then down to the next row. So across a row, then down to the next row. Keep going, keep going, keep going. Good. Letter B, you were supposed to subtract A minus B. Subtracting each of the entries. So 1 minus 2. -1 minus -1. 2 minus -1. -1 minus 8. Are we doing okay with our arithmetic?
Yes.
Work carefully, don't make mistakes. 3 times A, this is what we call scalar multiplication. I actually gave you this as an example before. We covered it in notes. I thought you could do it because, what did you guys assume you were supposed to do? Exactly. So 3, -3, 6, and -3. Multiply each entry by the scalar, by the constant in front. Letter D. 3A minus 2B, there was a lot to keep track of. Technically, if you wanted, you could have written down the 3A, then done the minus and figured out 2B first before you continued on. Would have been 4, -2, -2, and 16. Some of you tried to do it all mental math. Let's see if it turned out. You end up with -1, -1, 8, -19. Double check, it's okay. 3 times 8, you guys already told me. I just stole the exact same thing from letter C. 2B was the second part of that equation, right? So doubling all of these entries, double checking real fast. 4, -2, -2, 16, good. 3 minus 4, got it. -3 plus 2, got it. 6 plus 2, got it. And -3 minus 16, got it. Careful, if you miss anything on this page, you gotta slow down on the mental math. Slow down on the mental math. Alright, kiddos, ready for more scalar? Here we go.
Oh, no.
We already wrote down. Don't worry, we already wrote down. Multiply each entry by the scalar. You guys knew what to do on the last page 3 times A. I'm just adding in a quick note. You can also factor out scalars to make the matrix prettier. Meaning, gross. They all have fractions. Yeah, what can we take out? Take out the over 2, we have to take out a 1/2. And what's left on the upper left or the A11 entry? How about the A12? A21? And A22. Every now and then it comes in handy. Every now and then it comes in handy. Specifically with matrix multiplication. Specifically with matrix multiplication. Austin, that was you, right? The row column thing?
Yeah.
Hang in there, it's coming. Go fast, don't get lost. There's some important stuff coming.
Don't fall in.
No, that's not nice. Alright. Properties. Now guys, hold on. You could write this entire thing, or you could just say, you know what? Do any of these not make sense? Commutative property still applies. A plus B, B plus A probably makes sense. Associative property of matrix addition. You can add B plus C, then add A. Or add A plus B, then add C. Probably makes sense. You can multiply 2 scalars, then multiply in, or you can multiply in one and then the other. Probably makes sense. 1 times any matrix is itself. Probably makes sense. You can distribute a constant, or I should say a scalar, to both matrices. Probably makes sense. And you can distribute a matrix to 2 different scalars. Probably makes sense. Okay, if any of these don't make sense, please feel free. The only one that's not written down that I thought probably should be is, I could say property number 7. A matrix, which we call just A, plus, we'll call it Z sub N. Technically, this could be an M by N. It doesn't have to be a square matrix as long as it's a 0 matrix. You guys also saw how that's always going to end up being the same. Equaling A. Now, once again, these all make sense. So the question is, okay, fine, is there anything in matrix operations that doesn't make clear sense? And the answer is yes. What Austin was talking about earlier, matrix multiplication isn't quite as straightforward as all the rest that we've done. So the nice thing is, hopefully most of what we've done is pretty straightforward. You're like, oh, fine, yeah, I get it. But matrix multiplication is a little more complicated than scalar multiplication. Definitely more complicated than matrix addition or equality of matrices. You guys have done. You just need to refresh the memory. Probably one of the things that most of you guys mostly remember is, in order to be able to multiply, these two have to match. The insides of the orders have to match before you can multiply. And then the outsides tell you what the new order or the order of the product will be. My way of remembering it is cross down. Cross down, and if possible, cross over down. Thinking about how, as you put in matrices to your calculator, you work by rows. First row, first entry, first row, second entry, etc. Then you go to the next row. Second row, first entry, second row, second entry. That's kind of how we do multiplication. Good timing, David. We just started in on what gets a little more complicated. Not a lot, but it definitely takes some time to get the hang of. And as you guys are going, let me show you what I mean by cross down. First with first, second, let me show it this way. Second with second. First with first, second with second. I'll show you how to put those operations together in just a moment. But do you realize how I'm going across the first matrix and then going down the second matrix? So first in the row goes with first in the column, second in the row goes with second in the column. Now, how do they go together? First of all, let's just make sure it's legal to do this multiplication. What order is matrix A? 3 by 2, rows by columns, right? What order is matrix B? So question, do the inners match? The answer is yes. So what is going to be the product's order? Yep. A times B is going to be a 3 by 2. Not randomly per se. We'll get to a word problem. Hopefully, I think it's in this section. It might be in the next, and maybe it'll help just a little bit to see how matrix multiplication can be applied. But for right now, we need to figure out at least how to do it. So, cross down. Work our way across the first column and down, across the first row and down the first column. So I said that -1 goes with -3. You guys can tell yellow with yellow, right? How does it go together? They get multiplied by themselves, or by each other, I should say. -1 times -3, they get multiplied by each other. And then think dot product. Plus, 3 and -4 also get multiplied by themselves, or by each other. So -1 times -3 plus 3 times -4. Now mental mathers, you might be able to, once you get the hang of it, do that in your head and come up with a number real fast. But just so that we get the hang of it, just so that we get the process down, the formula down in a sense, we're going to show all the work for this very first one. Okay? Now, cross down. We did first row, first column, and guess what entry first row, first column gets us? A11, first row, first column. That's going to get us A11. Now hold on, we have a lot more of our matrix to figure out. So I said cross down, then cross over down. What do I mean by that? It's time to go to the next column. We have to finish the first row entirely. And in a sense, you can think he has to distribute to the entire second matrix. So then we're going to finish our row by going across, and we're going to have -1 times 2 plus 3 times 1. First row, first to the second column. First row, second entry with second column, second entry. And that's going to get us A12. First row, first column. Except it's the entire first row and the entire second column that we're putting together with this pattern of first times first plus second times second. So I want you guys to go ahead, take a second, and see what would change or how to keep going if I change my highlighting to be the second row now. And if it helps, I'm going to close my matrix and say that's as far over as I go. Remember, we need 3 rows and 2 columns. See if you can continue the pattern. You want to look up, I've already highlighted to try to remind you. Second row, first column. Showing you the spaces we need to fill in. Let me go ahead and zoom in on the problem also so we can see a little bit better. I'm going to move my highlighting just so you can double check. You guys go across, then down, then across, and then over. Okay. You get 4 times 2 plus -2 times 1. you were able to get that, then I would say try to do it with no highlighting. Can you finish the last row without my putting any highlighting up whatsoever? Meanwhile, as you guys are trying to finish that last row, let me go ahead and write what we have so far after you simplify. 3 minus 4, nope, 3 minus 12 should be negative 9. Negative 2 plus 3 is 1. Negative 12 plus 8 is negative 4. 8 minus 2 is 6. We're waiting on our last two. You guys notice all I've done is pen dots. I multiplied, then added them together for each set of expressions for each of my different entries. Let's see how you guys did the last one. What'd you get as your first expression? Who came first? 5 times who? Not 5 times 0. 5 times negative 3. Remember, you need the first times the first. So you go across the row and down the column. The first times the first, plus. Go back to the row, second, 0. Go back to the first column, second, negative 4. Then we crossed over down, so going across, we still are 5, 0. We go down our 2, 1. So 5 is going to get multiplied by who?
2.
Plus. 0 is going to get multiplied by? So hopefully we end up with negative 15 and 7. Now kiddos, we are basically at the end of today, and that's okay. Check the backboard. What did I say for today? What was our goal?
Start.
Now pause before you get up. Did we do a good start?
Yeah. Yeah, we did.
But do we still have a couple things to do tomorrow?
Yeah.
Alright, so come ready for tomorrow, but if I were you, I would start your section homework because you definitely can. See you guys in chapel.
Thank you.
Thanks for your patience and
Have a great day. Let's do it.